Hello, my name is Flavius Penescu, and this is my Physics 2 Lab 3, Magnetic Bars. This is the table of contents. Okay, the lab purpose is to give students a better understanding of magnets, magnetic forces, and magnetic fields in the real world. The experiment observes the interactions of a bar magnet and its magnetic field with the Earth's magnetic field. We will use the formulas we were taught in class to calculate the magnetic field of the bar magnet that is used. Here are the fundamental physical principles. We have the magnetic field of the bar, the magnetic field of Earth, and then the natural log system that we will use in our plot. Here's the model of the lab setup. As you can see, we have the our phone distance both in the x-axis and the y-axis away from the magnetic bar. Here's the experimental data used. The initial conditions are that the bar magnet is only being affected by Earth's magnetic field. The system is the bar magnet, and the surroundings are the Earth and the phone. As you can see, the bar magnet is affected by the Earth's magnetic field. Therefore, our calculations for the off-axis field are used to identify the magnet's field. Here's the calculations. In the end, we found that mu is equal to 3.08 picometers per T. The observations we saw were that the when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnometer moves closer to the magnet, the measured x component of the magnetic field does not decrease. The position of the magnometer influences the measured x component of the magnetic field. As the magnometer moves closer to the magnet, the measured x component of the magnetic field increases. Here's the code used in the lab. These are the program outputs for the code and the outputs found using the data. The difference between the program and the real-world experiment is that the program makes assumptions, approximations, and idealizations. The similarities between the two are the fundamental physical principles used. Discussion question 1. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? In this case, the Earth's magnetic field would have a slight effect on the magnets, and therefore the results would be inaccurate. Discussion question 2. What if you were to stick two identical magnets together, end to end, and run the experiment again? How would you expect your measurements to differ? If this were true, the results would be the exact same. However, the magnetic dipole moment would be reversed in this case. Ultimately, we discovered the effects that the Earth's magnetic field has on a magnet, as well as a method to calculate the bar magnet's magnetic field. Thank you.